Yes, hello there. Himanshu this side, and I'm a physics faculty here at askIITians. Today I am going to teach you the chapter motion, and this is the lecture motion. All right. Before this, I hope you must have taken basic maths classes, active batch, or wherever you are. All right. So, basically, do in this chapter, and why do I recall the basic maths? Because whatever you have learned in the chapter, we are going to use them here. That mathematics which you have learned, that was very new. Like if I talk about the vector, if I talk about the differentiation, thing new for you people. So where do we use it? I hope this must be a very common question. So that I'm getting after attending this session. I mean the entire 3 lectures of this particular chapter. So chapter name which we are starting here with our physics portion is the motion. That physics chapter of the grade 9. So basically what we do here in the chapter motion, of course, if you are talking about the velocity, speed, acceleration, around that only, right? And the basic idea you guys grade 8, right? And it in the grade 6 as well. This is not something very new for you people. Here you would be getting some extra portion and some mathematical part also will be covering here. So purpose this chapter would be solving. Let me take it to become a scientist, and now you are a scientist at ISRO, let's say. So now you are launching a rocket. So in that way, in some news or somewhere on the social media, that they can easily predict location of this rocket time, right? When it will leave the Earth's gravitational field, when it will enter the surface of this particular planet, या फिर when it will be this particular orbit. These you must have seen. So that requires a little bit higher mathematics. Simple version of such type of questions we would be dealing here in this chapter. If you see the physics part, then the entire physics is divided into 2 sections. The entire physics is divided into 2. One is called the kinematics. I'm talking about the mechanics part of the physics. So one is called the kinematics, and next is called the dynamics. The second branch is the dynamics. What does it mean, kinematics and dynamics? We talk about the mass particle bodies here, right? And kinematics means finding the future of the particles. Start from your home, and you are on a motorbike, and let's say meters per hour. Now I can predict very easily that after 5 hours, you must have covered 30 multiplied 5, 150 kilo distance. I can predict this. That's called the predicting the future of the particles, right? Similarly, if somebody the body is going with a speed of 100 kilometers per hour, and right now it is at x is equal to location, can you predict where the body was 2 hours before? We can do that. So predict the future of the particles. Okay, and in the kinematics branch, are mainly dealing with the bodies like truck. In our curriculum, I'm talking about the truck, train, and then a stone thrown upwards like that. So in this kinematics branch, you don't go to the core. Suppose I threw in the vertical upward direction. Now the stone goes up, and then what do we observe? That after some time it will be coming back. That's our observation. You go up, and then after some time it will. You will be just predicting after how much time coming back in this chapter. But In the dynamics branch, you try to find out the why did it go up? Question number one. Why did it? Question number two. And then why it comes down? What is that something which is bringing this stone back to the ground? Start answering the question why. Then you are into the branch. So this question you'll be answering in the dynamics branch. But what is the future? That you'll be answering in this. So what question is being answered in this particular chapter? And why? These two particular questions we deal with. So in kinematics branch, motion in one dimension, motion in two dimension. And dynamics branch, the Newton's laws of motion, the cause part, right? So this is the cause. And here you observation, just doing the observation, where the particle would be and like that. Not interested in knowing why the particle is moving like this. What is the that fourth term we'll be using in the dynamics branch. So now going ahead, discuss with you in this chapter. It's a kinematics branch where we are going to discuss the question. What and what will be the future of the bodies like that. So it was a quick introduction to the chapter, and we will talk about the different types of motion: uniform motion, non-uniform motion. Then there are some terms related to it: distance, displacement, speed, velocity, and so all these things we are going to discuss in this particular chapter. All right. So now let us begin with the first of all, defining the state of a body. Very common question. Suppose if there is a person standing here, his name is, let's say, Sonu. Sonu is standing here, right? If you are attending my classes, my favorite student. So Sonu is standing here. If you ask Sonu what this guy is doing, let's say his name, what this Sonu would answer that Monu is sleeping. He is at rest. Now, if you ask Sonu what this guy is doing, let's say his name is Tonu. So what Tonu is doing, then you would answer that Tonu is in the motion. Yeah, he is running. Okay. Let us understand the same thing in some different example. The rest and motion. So now let us bring another example. 3-person we can take, 3-person we can take Sonu, Monu. All right. So now let's say the Sonu is standing here. And we have a car. That car is, and this car is moving with a velocity, constant velocity. It is covering 10 meters of distance in 1 second. I hope you know the general meaning of velocity. Distance covered, displacement covered per second, or you can, it is covering a 10 meters of in a second. Now, there are 2 persons sitting inside the car. His name is Monu and his name is Tonu. So Sonu and Tonu, these 3 are the people about which I'm going to talk about you. And let us ask some questions, people. We are not sitting here right now. We are not sitting here right now. We are somewhere else, not even present in this scenario. I'm going to call first of all the guy called, and then I will be asking the same question to Monu. What is the question? Same question I am asking to both the people, Sonu as well as Monu. The question is, what is the state of, common question. Same question I would be asking to Sonu, and same question I will be asking to Monu. So first of all, if I ask Sonu the state of Tonu, that's the question. What is the state of Tonu? First of all, I am asking to Sonu. what he would answer? I hope you are all same way. He would say that Tonu is in motion. Exactly. Now it's a blue color thing is a car. Now I am asking the same question to another guy, Monu, who is sitting in the same car along with Tonu. They are talking to each other. I'm asking, going to call him again, that Mono, what is the velocity of Tonu? What he would say, Tonu. He would say, Tonu is sitting here nearby me. So Tonu is in the state of, Tonu is in the state. So the question was, what is the state? The guy saw Tonu is in motion. And the guy Mono said that is in the state of rest. Now, and Mono both are your good friends. You know them very well. So you won't be thinking that who is lying. Okay. So both are your good friends. So you believe them that they be telling me the right answer. So you are sitting somewhere else. You don't know what is happening here. So first of all, you asked, said that Tonu is in motion. And then you asked Mono, he said Tonu is in rest. Don't you think you will get confused? The first intuition which will be coming in your mind is that someone is lying. Either Sono is lying or Mono is lying. But in reality, one is lying. They both right answer. Right? It's all about whatever Sono has perceived, he told you. Whatever Mono has perceived, he told you. Was according to them. So this answer of rest and motion, whether the body here, the object or the body is in rest or he is in the state, this is not this does not have a single answer. It depends whom you are asking. And then you need to know the information of that person also to whom you're asking. Now let me change the way of answering their question. That Tonu is sitting in a car and the car is moving with a velocity of 10 meters per second. So that's why I'm saying that motion. Now let me ask Sonu, this guy Mono, that he's in rest, because he will say, because I am also sitting in the same car, right? And that's why is at rest. With respect to me, for me, the Tonu is at rest. But for Tonu is in the motion. Rest and motion is an observer-dependent phenomena. Rest and motion. Rest and motion is not an absolute thing. That he is in the rest. I can always tell that he is in the motion. No, I cannot do that. So this rest and motion always in what? Is always a observer. So the place from all these observations, suppose Sono is making observation from here. So he will be fixing his origin, right? Origin he would be fixing somewhere so that he can calculate distance. That Tonu is at this distance, Mono is at this distance. In there. So for Sono, the origin would be there. And for Mono, where would be the origin? At his place. The origin is here. This is the origin for Mono. So for different observers, there are different origins. You're getting my point. So depending on their place from the observations, they will be giving you different answers, but nobody is wrong. It's all about the observer. So now there is a term which I'm going to define called the frame of reference. Frame means the place where you have set your origin. So Sonu has set his origin at this place. Sonu. For Mono, this is the origin. So this is the Mono's frame. So frame of reference. Reference. Frame of reference. What does it mean? The place where you fix your origin. In a simple language, the place where we make all the observations. This is what we call the frame of reference. You go. So that is the meaning of frame of reference. So if I say in another way, you should be confused now. Rest and motion depends on observer. Okay. Rest frame of reference. Yes, that is also correct. So this is what you will find in good books. That rest and motion is not absolute, depends on the frame of reference. So this is what the meaning of frame of reference. We make all the observations, that is called a frame of reference. All right. So now always keep this thing in the mind, that what is the meaning of frame of reference. And rest and motion, frame dependent phenomena. Got my point? Okay. So this is somewhat related to the relativity. Right. Relativity also talks something like that only. Right. Different observer, you know, a satellite which is moving with a very high speed, someone is sitting in some different place. Here you apply the relative velocities concept. I hope you got my frame of reference. Okay. So going ahead now, we are starting. This is called the motion. And we have understood what is motion. If something, if some distance is changing with respect to you, right? So let's say you are sitting here. This is your frame of reference. Okay. And now let's say there is a particle. That particle distance is meter right now. If after some time a particle comes here, let's say this distance becomes 100 meter, then you would say that this and the particle is changing, which means that the particle is in the motion. The particle is in the motion. If the distance between you and the particle, you would say that particle is not in the motion, he's in the rest. That's how you define it. If something is distance with respect to you are doing the observation, the person who's doing the observation, he would say, respect to me, so the thing is in the motion. Now, what is motion? Very simple. Let us take the example of this car. You can see this car is starting from the location x is equal to 0 meter. After 2 seconds, this car comes to x is equal to 4 meter. After another 2 seconds, the car comes to the meter. After another car comes to the location x is equal to 12 meter. So this basically, if you look at the motion of this car, then in the first 2 seconds, the car covered a 4 meter of distance. In the next 2 seconds, the car covered a total distance of again 4 meter. These are the coordinates, guys. X is equal to 8, x is equal to 4, coordinate. So what will be this difference? Difference will be again, this difference was also again, this difference was 4 meter. So all these differences are you getting my point? So basically the distance traveled is equal in equal intervals of time. In each 2 interval, the body was 4 meter of distance. That was just an example. So how do uniform motion? In a single way, in a single form. Right. Uni means in a single. Uni means itself a singular thing. Form means a type. So basically, mean that a single of motion means when a body travels equal distances in equal intervals of time, we call it a uniform motion. Going ahead now, uniform motion. If body covers unequal distance interval of time, suppose x is equal to 0, time is equal to 0. Let us take x is equal to 0 here. Time is equal to 0 here. And now let's say the car is there again and the car starts from here. After some time, car comes to this. After some time, car comes to this location. Then car comes to this location. So let us see distance is traveled by the car. If the numbers are like this, x to 10 equal to 2 seconds, x is equal to 12, after at t equal to 4 seconds, at I'm saying at, that's not an interval, 4 seconds, that's a particular time, t equal to 4 seconds. X is equal to 15, okay, and t is equal to, let's say, 6 seconds. What is this time interval, guys? 2 seconds. Time interval? Again 2 seconds. What is this time interval? Again 2 seconds. So in each and every 2 seconds, we can see the body is covering in the first 2 seconds. Then the body has covered 2 meters of distance in the next 2 seconds. Then the body has covered 4 distance in the next 2 seconds. So interval of time, distances which are covered by the body are not equal. They are unequal. That will be defined as a non-uniform motion. Now the people who remember the speed concept from the grade 8 or lower grades, they would say that the body is not going with a uniform speed. If you go with a uniform speed, so you are supposed to cover equal distances in equal intervals of time. Right now, the equal distances, you're not equal intervals of time, so you're not going with a uniform speed. So non-uniform speed. Or simply I can say the speed is not constant. The speed is not, but in the previous say that the speed is constant. Very good concept. Uniform motion. Constant, uniform motion. Speed is not constant, non-uniform motion. Got my? Okay. Now I'm going few more terms which I'm going to define now, which is called the distance and the displacement. So what is the meaning of distance? You guys know it from your previous also. Distance means the total path length. So if you look at the motion of this lady, then from where she is starting, let's say she is starting from the location A. From where? Here. Let her come back. So she starts from the point A. She goes to C, B, and then she goes back to A. You can see she's starting from their position A. Let her come back. Yeah, come back. Then going to B, then coming back to C, then going back to A. Got my point? Now see. First of all, she started from the location. This is the lower thing, numbers you can see. She goes to point B. Total distance covered is 100 meters in the upward journey. 100 meters. Now she comes back to A. Again 100 meters. So total distance covered 100 plus 100 is equal to 200. So which this lady has covered is how much? The total path length is 200 meters. So basically the actual length which you have to cover, that is distance, total path length. When you start from A, then C, B, then you come back to A. It's very simple. So distance, to calculate distance, you need to know the actual path which you have taken. So you want to go from your home to, let's say, railway station. There might be different ways to go to railway station. It's not a single way. You can go to railway station by some different paths. Suppose this is your home and this is the railway station. So somebody can take this path. Somebody can take this path. Right? Somebody can take it. Actually, let me draw the arrows as well here so that you can get to know. Like this. Somebody can take this path. There are different ways to go from home to the railway station. So if you want to find out the distance covered, it is not like that you will calculate the distance of the road length of the any particular path. No. You have which path you have, and after getting that path only you will be able to distance you have to travel or this much distance you have traveled. And then you will be able to find out that yes, if you have taken this path, then that means this much kilometer you must have traveled, this much amount of fuel you have to spend. Okay, so this much amount of rupees you will be charging. Got my point? But if I talk about the displacement, so this is what actual path taken to find out the distance. If I talk about the displacement, what is displacement? Shortest distance between initial and final position. Shortest distance between initial and position. This is very simple. Point, the starting point, destination point. Starting and destination. Think about it. If you want to find out the shortest distance, what it would be? Would it be a curve? Can it be? You want to say that the shortest distance between the 2 points? It can never be a curve. Always remember, shortest distance between the 2 points is always a straight line. It is always a straight line. Shortest distance between the 2 points is always a straight line. So if somebody goes from one, then displacement would be the straight line joining the initial point and the final point. Now, doesn't matter which path you take. Doesn't matter whether you take this path or you take a different path. Suppose somebody take this path. It doesn't even matter. I won't even ask him. If somebody tells that I want to go from location 1 to 2, I would not ask him the path, the displacement, because it does not depend on the path taken. It depends on the initial and the final point. You just have to find out the straight line distance, this red color line distance. That would give you the... to find out the distance, you need to know the path. Got my point? So just think about it. One question, suppose let's say somebody is going from the location 1 to the location 2. Right? So now if he travel, now if he wants to calculate how much fuel I'm costing for me. Somebody wants to travel from location 1. Now if he or she wants to calculate how much fuel it would be costing for me. So if I tell you spent would be 30, helpful for him? Information won't be helpful for him. Maybe this path is not possible. It's an imaginary line you have drawn. You want to calculate the cost of fuel. You need to know the path taken. So to calculate such things, if is demanding such things, then you should find out the value of distance, displacement purpose. You will learn it later on. It's to calculate velocities and all, and those things will be getting some other stuff. So displacement would not help you there. Did you get my example? That if you want to go from location 1 to location 2 and you want to would be costing. So for that you should not calculate the displacement because it is not possible. That path itself is not there. That pathway is not possible. So to calculate the amount of fuel, you can to know which path is possible. So this is one of the possible path. This is one of the possible path. Let's say 2 paths. Let's say this path is consuming only 30 kilometer. And the another path is 60 kilometer. And then you will calculate, okay, yeah, there are here to there. The Google map is showing you 2 ways. So now you can say that I would be taking the 30 kilometer path because there's traffic as well as the fuel costs. The red color line is an imaginary line. Possible if there is a from location 1 to location 2 straight over bridge. You can take that path. But that is just a way to calculate displacement. Right? So to calculate the fuel cost, you need to know the actual path. I hope you got my point. Okay. So that's the meaning of distance. Always remember, if you want to calculate a displacement in any question, forget about the path. Just join the initial and final point. Write down in your notebook. To calculate the displacement, just join. That's it. Nothing else. Some numericals on it. Okay. So if we do some numericals, then yeah, for a simple question. So what is this question saying? A runner travels around a rectangular track. So let me draw one rectangular track here. First of all. So that is the rectangular track. Length is 50 meter. Width is 20 meter. After travels around rectangular track 2 times, comes back to the. So basically what happens? The runner starts from here. He runs like this, like this, like this, like this. And now one. Again, he would start from here. Second time. Second round trip is done. So basically 1, 2, 2 is done. Entire track. What is the distance? Calculate in your notebook. It's very easy now. You can do it. Just calculate the total path length. It starts from here. Let's say this point name is A, and finally comes back to A. So total path length. So 50, then width covered, this distance 50, and then go again 50. Got my point? Right? So whatever you have got, just make double of it. True? Going from here to here, then going here 20, 50, then going here 20. So 20, 50 plus 20, sorry, this is 20. So what is the total distance you have covered? And that you multiply by 2 because 2 times you have done the same thing. Which you have done is how much? 2 multiplied. I think I should change the pen color, not visible. Yes, let us take the different color, black. So 2 times of 50 plus 20 is 70. 70 plus 50 is 120, 140. 280 meters. That's the distance. But what is the displacement? Join the initial and final point. This is the final point. Join them 0. 0. When you join them, it will be 0. So now you can remember one thing. When initial and final point same, displacement is always. When initial and final point are same, initial and final point same. The displacement is always remember this. Always remember this as a fact. Okay. And you should also, it's not a very difficult thing. Let's take one more question. This question is a challenge for you. You should try to solve this question. Simple maths. I'm drawing one track here. Okay. So that's okay, correct. Now, let's say somebody starts from here. So first of all, then he'll go to this location, then he'll walk, then he'll go Then again he'll climb up, then he'll again walk, go to this location, then again climb up and then goes to this location. So destination is B. Starts from A and final destination is B. Distance traveled by the body, displacement traveled by step length is 1 meter. Each step length is 1. Pause the video here. Pause the video here and try the question. Hope you have done it now. So I'm solving it. So basically, you should not see the solution directly from me. First, you should try yourself to solve the question. So now 1, 1, 1, 1, 1. Total path length is a distance. So 1, 2, 3, 4, 5, 7. Distance. What about this? Never get confused to find out the displacement. What I do, I just draw a straight line from initial to final. That's the displacement. Join the straight line from A to B. With this straight line, physics is over. Now here comes the mathematics part. What you should do, see here. Make a horizontal line here like this. This you have to think. This will come with the practice. You should practice more and more questions. This understanding will come with the practice. How to think in different. This is a horizontal line and this is a vertical line. The angle between them is 90 degrees. Got my point? This is a vertical line. Between them is 90 degrees. Horizontal vertical angle is 90 always. So now, what will be this distance? Put it. This horizontal distance. This is 1. By this would also, because see, it is parallel to this only and same length exactly. By the same logic, this would also be 1. Same logic, this would also be 1. So 1, 2, 3, 4. Total this length is 4. Now you can calculate the vertical also. This is 1. This is 1. Same logic. This is 1. See, because this is 1, this is 1, this is 1. Add 3 of them, you'll get total distance is vertical, 3 meter. Length, sorry. 3 meter. This is 4 meter. And now you know what to do. What you have to do now? You just have to apply Pythagoras theorem. This is 3 meter. This is 4 meter. It's a right angle triangle. This will be square root of 3 square plus 4 square, which would be equal to 25, and that is equal to 5 meters. So displacement answer is very. Don't take much tension to solve the displacement question. Just join the initial and final point. You will see the questions in your study material or in your textbook that there is a circular track. Cyclists start from point and let's say it is the center and reaches at the diametrically opposite point. So calculate the distance traveled by the cyclist. So parameter. So total length is 2 pi r and half of that would be pi r. Displacement, just join initial and final point, 2r. That's it. Very simple question. So many questions you will find of such type in your textbook, in your NCERT textbook. It's not a very big deal to solve distance displacement questions, I hope. Our next topic now, which is the last topic of this session, average velocity. First of whenever I average, the first thing which comes in my understand the average speed, average velocity is very similar to this. So more time on average speed only. Average one thing will be changing. First of all, what does average speed? Why it is to calculate the average speed? All such questions we will be answering now, right? So try to understand this, right? That why do we need to the average speed? What does it help you? And what is the significance of it? Let us see. First of all, I'll start with a question. Let me ask you a very simple question. There is a class of 3 students, okay, and 6 paper for them of 100 marks. I have taken marks paper for them. Okay. Student 1, 80 out of 100. Student 2 scores 70 out of 100. And student scores, let's say 30 out of 100. Okay. What would be their average marks? These are the marks which I have given you. What would be the average marks for the entire class? Average AVG is the short form I'm writing here. Average marks of the class. The average score of the class. You will say that, sir, add all of them and then divide by 3. We will do. Add all 3 of them. 3. My point. Okay. Do it 150 plus 30 divided by 3, which is giving you 180 by 3, which is 60. So the average score for the entire class. I can easily say that. Yes? Okay. Let me bring the same physics. That's a mathematical average you have calculated. Suppose a body starts from here. It goes to B with a velocity of 80 km per hour. Then body goes from with a 20 km per hour. And then body goes from C to with a velocity of 30 km. This is the information given. That a body starts from A, it goes to B, it goes to D. And these are the velocities which the body is traveling. Calculate the average speed. Calculate the average speed. Now my teacher has told me that average, we always calculate. Must have learned it. Right? I also learned it in the grade 8 to calculate the average. Calculate the average of 3. So what we do for that? We first of all calculate first of all add 3 numbers plus 70, 30 divided by 3. Answer would be 60 kilometer per hour. And then you write down this answer and you don't get any marks. It would be wrong. Average speed is equal to 80 plus 30 divided by 3. This is completely wrong. Completely wrong, completely wrong. Average speed, the name is same, that average. But if the name is same, this does not mean that way of calculating is also same. So in physics, average concept. Okay. And what does it represent? Because it has some significance. That is why. Got. I'll explain you. Okay. So now, first of all, it is not a mathematical average. Then what does it represent? It represents that how do we find it out? First of all, total distance upon total time. That's the meaning of average speed. Total distance upon total time. That's the meaning of average distance. Got my point? Calculate average speed. Don't worry, we will discuss the meaning of average speed also. Just a second. Let's first see how do we define physics. Total distance covered for the entire journey for which you want to calculate the average speed. Divide this number by the total time taken. That's what will give you the idea about the average speed. Let me explain you this part here. The average speed. Yes, we can discuss here. Yeah, we have the blank. Let's discuss. Suppose again I'm taking the similar example. A body starts from A. Some values I will be taking. It goes to B. Yeah. It goes to B with the velocity of 20 kilometers per hour. And let's say it travels for how much time? 2 hours of time. A to B, you drive for 20 kilometers per hour. Okay. Then from B to C. Oops. Then from B to C. From B to C, let's say you travel with the velocity of 40 kilometers per hour. And the time which you have taken is, let's say, 4 hours. Or let's take some different number, 5 hours. And then you go to D. The time which you have taken to cover this distance is, let's say, 1 hour. And the velocity, the speed with which you travel from C to D for the entire path is, let's say, 50 kilometers per hour. Can we calculate the total distance here? Let us do it. Total distance. Just focus here for the 5 minutes. Over the next 5 minutes, just focus here. It's a very important concept. To understand this, you should not get the wrong idea about average speed. Total distance. Here you cover with 20 kilometers per hour from A to B. So distance covered in A to B plus distance covered in B to C plus distance covered in C to D. How much distance you have covered in going from A to B? 2 hours you travel with a speed of 20 kilometers per hour. In 1 hour you travel 20 kilometers, so in 2 hours you will travel 40 kilometers. B to C, 5 hours you travel, the total distance would be 200. C to D, total distance 50. It's very easy. Simply you can just multiply the distance with the time with the speed. 240 plus 50, 290 kilometers. And total time we have taken? 2 plus 5 plus 1, 8 hours. So technically the way we have defined the average speed, what should come out to be? Average speed should come out to be? Average speed should be equal to total distance upon total time. So total distance is 290 and total time is 8 hours. So kilometer per hour. That's the unit. to measure the speed, right? So kilometer per hour, meter per second, whatever, feet per second, whatever you use, depending upon the distances, the scale which you use. So A to B, B to C, C to D, the entire information was given, right? Let's say again, I am calling those two people my favorite guys. First of all, let me call Sonu. Sonu has done this. He went from A to B, B to C, and then C to D. And these are the distances which Sonu has taken. 20 km per hour, 40 km per hour, 50 km per hour. So Sonu goes with a bike, and these are the speeds which Sonu has taken. Now there is another guy, Monu. He also wanted to go from A to D. Imagine that this is the only way possible. There is no other path possible. That's the only way possible. B, C, D. So Sonu also wanted to go. Let's say, who is standing here? Tonu. Tonu is standing here. Let's say it's Tonu's marriage. So they both are going to Tonu's marriage, right? So Sonu is also going, and Monu is also going. They both are going with a different bike. So Sonu is going with this speed, 20, 40, 50. He travels the total distance in 8 hours. And he goes with 3 different speeds. And he reaches at that point D in total 8 hours of time. Now Monu said one thing. I will also take the same path which Sonu has taken. I also want to go to Tonu's place. I will also take the same path. Exactly same path. I also want to reach in 8 hours of time. I also want to reach in 8 hours of time. Listen me carefully. Sonu and Monu both are going to the same place D. Right? Sonu is taking 8 hours of time. Monu will also take 8 hours of time. That's the condition Monu has put. But Monu said one thing. That I do not want to go with different speeds. 20, 40, 50. I'll start my bike from here and I'll go with a uniform speed. I will never change the speed. I will not do it like this 20, 40, 50. No. With whatever speed I'll start my bike, I do not want to accelerate it. I do not want to retard it. I want to go with the same speed. So at which speed should I go? Listen to me. At what speed? At what speed? Monu should drive so that he reaches the Tonu's place. So that he reaches at the Tonu's place exactly after 8 hours. At what speed the Monu should drive the bike so that he also reaches at Tonu's place exactly after 8 hours without taking any time. Exactly after 8 hours and no more less same time 8 hours. But he does not want to change the speed. So that answer would be that he should walk with an average speed. Average speed of Sonu's numbers. So we told him that you should go with this speed. So he calculated, he did the calculations. That suppose if somebody goes with this speed, 290 by 8 kilometers per hour, then in 8 hours, how much distance he'll be calculating? He'll be getting. So in 1 hour, you cover how much distance? Unitary method, 290 by 8. See, that's it. That's the speed is given. In 1 hour, you travel 290 by 8 kilometers. So in 8 hours, how much you will cover? In 8 hours, 290 by 8 multiplied 8. Answer is 290 kilometers. So exactly same distance he would also be covering, Monu. So Sonu is going with different speeds, but Monu is going with single speed, and he is also reaching at the same place D. Tonu is or Tonu's place. But Sonu is covering different distances with different speeds. But Monu is covering with the same speed. And what should be that same speed? So that he also reaches at the Tonu's place exactly in 8 hours. That speed should be average speed. So that's what represent the average speed in physics. It will tell you the overall process. If you want to cover with a single speed, it will give you the idea about it. Got my point? I hope you have understood it. If you haven't understood, you should spend some 5 minutes of time. Think about it. What did I say? Okay. So now let us do one question. Now doing a question is very easy in physics because you just need to understand the terms that total distance upon total time. So here it is given that a car travels half of a length with S. So total length is S. Total length is S. Let us mark few points A, B, C. A to B, car travels with the speed v1. Now you read this language carefully. Second half is covered with velocity v2 for the first half and remaining distance with v3. Means AB he has covered with, AB is what? S by 2, half. Now half of BC, he covers with v2. What is half of BC? S by 4. Because BC itself is S by 2. Half of it would be S by 4. What's my point? Half of BC, half of S by 2 is S by 4. And the remaining distance with V3. So V2 for the first half and remaining distance with V3. This is also S by 4. Calculate the average speed of the entire journey. Very simple. Average speed is equal to total distance upon total time. What is the total distance? S. Total time. Let us calculate now. Total time we can calculate now, just a second. Yes, here let us calculate. So time taken to go from A to B, time taken to go from B to, let's mark this point as O, B to O, and then to go from O to C. O to B, time taken. Now distance, speed is equal to distance upon time. So time is equal to distance upon speed. So from A to B, distance is S by 2 and speed is V1. So S by 2 V1 plus B to O, S by 4 V2. O to C, S by 4 V3. That's the total time taken. Distance upon speed simply. So what is the average speed? S divided by S by 2 V1 plus S by 4 V2 plus S by 4 V3. S will get cancelled out from every term. And what you will be getting? Average speed equal to 1 by 2 V1 plus 4 V2 plus 4 V3. That's it. That's the final answer. That is the final answer. It's a good question. It's confusing sometimes, but it's a good question. Right? So you should read the question, break the question. First you read the question till here. Then you read the question till here. And then you read the question from here to here. And start solving it. So in such type of questions, sometimes they don't even give you the value of displacement, total distance. Okay? That's the meaning of average speed. Total distance upon total time. Now let's go to average velocity. It's a very simple thing. Average velocity is nothing but total displacement upon total time. That's it. For speed, you use the term distance, and for the velocity, you use the term displacement. The total displacement upon total time taken is called a velocity. Got my point? Yes. So now let us take one question here. Suppose, before this, let us understand one more thing. Suppose, let's say, a stone is moving from here to here, A to B, and then you come from B to A. The stone is coming back from B to A. Started from A, came back to A. What will be the total displacement? Zero. Starting final point same. So what will be the average velocity? Zero. So average velocity calculations are not tough. Once you know how to calculate total displacement. Am I clear? Very simple. All right. So that's why I'm not spending much time on it. Let us do one more question. Okay. A car travels 30 kilometer at a uniform speed of 30 kilometers per hour. 30 kilometer speed 30 kilometer per hour. Let's say A to B. What should be the speed for the next 90 kilometer? See how the question they are framing. If the average speed of the entire journey is 60 kilometer per hour. So this they have not given. From B to C with what speed it travels? That is not given. Distance is given. So what is the total average speed? 60. Average speed is given 60 kilometers per hour. We know average speed is equal to total distance upon total time. What is the total distance? You can see it very clearly here. Total distance, so 60 is the average speed is equal to total distance upon total time. Total distance 120. Total time, so again to calculate time, divide distance by speed. So from A to B, distance 30, speed 30. Plus from B to C, always take care of units also. Let me check in the previous question again. In the previous question there was no unit. You should convert into meter per second if they are of different units. From B to C, distance upon speed 90 by V. That's it. Now we just have to calculate it. So 60, this will get cancelled out 2 times. This will get cancelled out 130, 1 is a 30. So now how we can write this? I'm multiplying this, cross multiplication of this. So I can write 1 plus 90 by V is equal to 2. 1 plus 90 by V is equal to 2, the cross multiplication. And this side will become 2. So 90 by V will be equal to 1. So V will be equal to 90 kilometers per hour. That's an average speed. That's it. That's how, not the average speed, the speed for the next journey, B to C. Average speed was given here. That's how you solve the questions here of related to average speed. So simple thing is total distance upon total time. Always remember. So quickly, let's have a recap. So we talked about the frame of reference, the place from where we make all the observations. We talked about distance displacement. We also talked about the concept of uniform, non-uniform motion, equal distances and equal intervals of time. We talked about the average speed, average velocity, which I have taken around 15-20 minutes. You should re-watch it if you haven't understood. But it's very important to understand this discussion, which we have done here. What is the meaning of average speed? So it's that speed with which if you go, then it would be equivalent to the Sonu's journey. Okay. So that's the meaning of average speed, and average velocity is simply total displacement upon time. Right. So that's all from my side. If you have any doubt, if you have any confusion, you can comment on the batch discussion forum. So that's all, guys. Thank you so much for watching. Bye-bye.